This lesson is for Advanced Algebra, Lesson 6.6, Fitting a Quadratic Model to Data. And the way that you'll do that is you'll use quadratic regression. Now when you find a quadratic model, you can either do that by hand or on your calculator. And know that with the use of our CAS calculators in our class, we have eliminated using the by hand version. So whenever in the homework they ask you to find a quadratic model, you will always do it on your calculator using quadratic regression. So the steps for doing that are right here for you. You're going to type your data into a spreadsheet on your CAS. Then you're going to choose these buttons on your calculator. You're going to hit Menu, Statistics, Stat Calculations, and then you're going to choose the one that says Quadratic Regression. Now be careful, there is one that says Quartic. Make sure you pick the one that says Quadratic, not Quartic. So if you need to write yourself a little note on that, do not choose the one that looks like this. Once you have done quadratic regression or chosen that value, then you may get some pop-up windows. Just verify the information there is correct and then simply say OK. When you're all done, you'll see a screen similar to this. It'll say regression equation, and it'll give it to you in basic form, and then it'll give you an A value, a B value, and a C value. So you just grab those values and assemble it into an equation. So we're going to try a quick example here. Before we do that, let's review again that quadratic models, there's two of them that we've studied. There's the standard form, with the A and the B and the C, and then there's also vertex form that we've also studied. And that's the one that has y minus k and then the x minus h. The h and the k represent where the vertex is located. So here's an example of a quadratic regression problem that you may encounter. They may give you a picture with some coordinates that you could locate, or they may give you simply some coordinates. So here I've given you both, but know that they may only give you one or the other. So in this case we've identified -1, 7 is here. It's the first coordinate given. 1, -3 is right here. And then 5, 1 is here. Notice that there are other values available on this particular parabola, but those are the three that they identified for us. Now they want you to find its equation. So you will need to assemble that data into a spreadsheet form. So remember, when you go to your spreadsheet, you've got two columns to work with. So you have to just make sure that you're putting the numbers into the columns correctly. So typically I tell kids to remember that you're making a table of your x and your y values. So your first coordinate is -1, 7. Second coordinate is 1, -3. Third coordinate is 5, 1. So when you're putting that into your spreadsheet, the x's will be in column A and the y's will be in column B. So take a moment right now and go ahead and create a spreadsheet on your CAS. Type in the data into columns A and B. Remember that you will need to highlight those columns before you choose Menu, Statistics, and Stat Calculations. Remember that to highlight, you'll arrow all the way up, and you'll have to use your Shift key to highlight both columns at the same time. So arrow all the way up, then hit Shift. You don't have to hold it down, just hit the Shift button and highlight both columns. Then choose Menu, Statistics, Stat Calculations, and Quadratic Regression. And you should get the same values that I got. Now that you've gotten your values, now you assemble it into your final equation. And typically when you're going to do these regression problems, since they're giving you an A and a B and a C, most of the time you're going to be writing your answer in standard form. So our A value is 1, so you can either say 1x squared or just x squared. The B value is -5, and the C value is 1. So you do need to say +1 there because there is no variable to hold its place. So then that's your final equation. So that's one type of problem that you may encounter if they give you a list of coordinates or a table of coordinates or a graph or both. You make sure that you put the data into spreadsheet form or table form, type it in, and highlight and choose quadratic regression. There's one more problem that we're going to do together, and that is number 8 in the homework. It looks like a long, difficult problem, but it's actually fairly easy. It's another type of problem that you may encounter. So let's read it through carefully. In The Greedy Triangle by Marilyn Burns, an equilateral triangle keeps changing shape into a regular polygon with more and more sides. As the number of sides of a polygon increase, so do the number of diagonals of that polygon. Recall the formula for the number of diagonals of a polygon? If you've forgotten, you can derive it or get it from using quadratic regression. And that's what we're going to do today. Count the number of diagonals in each polygon below and complete the table at the right. So by organizing this information into number of sides and number of diagonals, essentially what we're creating here is x and y values, which will turn into then our A column and our B column when we type it into a spreadsheet. So if you look at the first picture or the first polygon, that has 3 sides, and it does not have any diagonals. The diagonals are pictured here by the dotted lines. So the number of diagonals for that one is 0. Then on your quadrilateral, 4-sided shape, it's got 4 sides, obviously, and it's got clearly 2 diagonals. Then you continue on through the rest of the 2 pictures. So go ahead and take a moment to figure out how many sides you have on this one. Should go in order. And then count your diagonals. For this one, I would recommend that you use your pencil so that you don't repeat. So if I start, there's 1, 2, 3, 4, and there are 5 diagonals there. And then do the same thing on the last one. Pause the video to do that. Should know that it's a 6-sided figure. Count the diagonals after you've paused the video, and you'll find that there are 9 diagonals there. So now that you've got your table, go ahead and use quadratic regression, type that into your spreadsheet, and come up with the A, B, and C values. So again, pause the video and take some time to do that. After you're done, you'll find that you get an A value of 0.5 or half, a B value of negative 1.5, and a C value of 0. Now they used N for their variables, and D if you wanted to use X and Y, that's also appropriate. I think they used N here for number of sides, and D here for number of diagonals, but know that you could have used X and Y as well. The next question here is something I just want to cover. It's not necessarily something that you would need to know or come up with on your own. Is this model exact or approximate? This is an exact value. An approximate one would be the ones that you would find by hand. And again, we're not going to do those, so all of our equations here or models are going to be exact models. Now the last question here, hopefully you can figure out how to do this. Use the model to determine the number of diagonals in a 50-sided polygon. All you have to do there is determine if that's going to go in for N or for D. So if it's the number of sides that a polygon has, that would be your N value. So you're going to take your equation on just a calculator page on your calculator, and you're going to fill in a 50 for the N value. So you're going to calculate that amount, calculate that, and once you're done there, then you'll know your answer for question 8D. That is not given in the video. You'll have to come up with that on your own. Good luck.